Hello, this is Randy Roebuck with OmniAir. Sorry for that technical difficulty here. I lead the technology and certifications at OmniAir and be giving a Plugfest technical overview. Why the need for this Plugfest? It's a driver to push industry standards conformance and device readiness. Here the last 3 to 4 months, we've been defining test cases, getting them implemented from a standards or requirement standpoint, and we need to confirm these test cases in order to go to a certification scope release. It also allows test equipment implementation, evaluation from the industry, and certification process towards audit and qualification. We need the participation of the device manufacturers to provide a variety of devices across our test cases and test equipment verification. We also have test laboratory engagement and preparation for expanding their VX technology. We are transitioning from DSRC to V2X medium and its aspects. And all this together enables our certification scope release based on industry adoption. This fall Plugfest, 3 weeks, 3 regions, 6 locations, devices and test equipment at the test locations. We have virtual participation for all the parties through Microsoft Teams. There's over 300 V2X test cases with DSRC and C2VX radio medium. We have bench and field testing for Plugfest discovery and testing readiness. We have capability, we're testing to have capability, changeability, cooperation, and collaboration, the same as you get as the in-person Plugfest. Our goals is conformance, compliance, certification, all together giving trusted over-the-air communications and interoperability. OmniAir's device level testing methodology. We do black box over-the-air verification representing the V2X environment, which is the vehicles and infrastructure. What is OmniAir certified device? It's a device that's tested at authorized test laboratories with qualified test equipment to approved release test cases and processes defined by the applicable standards. Certification devices does not mean or be misconstrued as reference devices. Reference devices, we have a program which is a separate classification. Certification performance is an evolving process requiring industry participation and agreement needed for operational deployment and interoperability. Test cases are defined as the key element verification, but may not cover every element in the standard or the specification. A key aspect of certified device is surveillance, making sure that maintaining the device integrity in the environment at periodical checks. So it's just as important for device manufacturers to attend Plugfest in order to determine their readiness and gain certification, but also keep coming back and providing the devices to get checked to ensure that they're still meeting their requirements. Why certification for trusted device communications? You have an independent accredited test laboratory testing and test report. Its conformance and verifications per test cases of the standards. It provides consistency for device applications. It ensures interoperability among devices. It allows access to security credentials to known devices. It does minimize product verifications and change requests and controlled releases. All these devices can be found on the qualified device list on OmniAir's website for agency procurement, and also provides environmental control and inspection through surveillance. Plugfest, it's about discovery leading to readiness. It's about test cases leading towards scope release. It's test equipment leading towards its audit and qualification, its test laboratories leading towards audit and authorization, its bench and field testing leading towards validation, its devices leading towards ready and to apply for certification. The objective here is the IOOs actually request the meeting and reference to the upcoming OmniAir certification pub site listing for agency requirements calls out. We've done this in the DSRC VDX Release 1, where you can go to our website and you can see what that certification covers versus the standards and elements towards our certification. Here is a drafting of what we anticipate the C2VDX PC5 will look like. The ones that are in blue are new items that the standards are being released and we'd be moving forward. Our certification program elements and process flow. On the left-hand side, the test cases have been updated for this release. We have 5 SMS security providers now. We gained membership of MicroSec from Europe here in the last month. We have 7 qualified test equipment providers. The Southwest test tool achieved qualification status in the past month. We continue to have many authorized test laboratories with 7 for OBUs and 5 for RSUs. And we have 6 OBUs and 6 RSUs in the DSC Release 1 that has been certified. We hope that the certification scope will be released here and we'll have certified C2VDX devices here in the early part of next year. In the center shows our standard flow, where it's the device applicant, the test plan is generated, it goes to the authorized test laboratory selection, where the conformance testing is done, the interoperability and field verification is done, with a test report generated and the test report reviewed with a certification grant. There's also an optional step to test the production security certifications with verification, and the OmniAir mark is granted, placed on the parts and its documentation, falling under the OmniAir trademark and certification listing requirements. On the right-hand side shows the very detailed steps to go through to add stuff to our certification program. There are many standards currently in works. There's some that's very appropriate to be put under certification. There's some are not, and there's someone in the middle. So it goes from having a stakeholder or sponsor of a particular standard requirement, define the scope. We look at the requirements, test cases and procedures are generated, gets implemented by the test equipment manufacturer. It goes through Plugfest trials. Then we update the forms. We test devices against these specs. Then we audit and qualify the test equipment. Then we authorize the test laboratory. Then it becomes part of the device certification release. Here showing is the first page of 4 pages of the certification test case list for this Plugfest. This particular document can be found on the VDX SharePoint repository that people will be checking off to see how they're doing in these test cases here in the next 3 weeks. This sheet here shows our test conformance specification listing that's either been released or in works or future. On the right-hand side are the documents that have been finalized for this Plugfest. You can see on the top there's the test plan for this Plugfest that can be retrieved. It does have 2 unlocked columns where you can write notes in them. The next documents are all the test procedures from the different test case elements. And the last sheet is a test specification comment. So we basically want all the folks to go through it, make sure all the test cases are achieving what they're supposed to. If there's any things that we need to modify, we welcome your comment sheet where we can address them and update the procedure before we approve the final certification scope release. This shows the testing configurations, the different elements, how many test cases they are, whether the device is tested cabled to the test equipment or doing a wireless test where appropriate. There's a listing of the bench tests there. We also have the field testing and the interoperability. Security certificates and common test routes. We have 4 certificate providers have offered their certificates for this Plugfest. Everybody's received the instruction list, and everybody should have loaded one of their certificate providers on their particular device. Here this week, I've gotten all the common test route files. I've incorporated 3 out of the 4 into a test route file. We're in the process of adding auto crypts into that where I can distribute to the test equipment manufacturers and the decoders for this Plugfest. Also at this Plugfest, we have added a portable router where we actually has a public static IP4 address with IPv6 tunneling, and there's complementary Hurricane IPv6 service through there. This is very important for us because to provide this capability, it's costing us about $10,000 per Plugfest to provide this capability. And now with this router, we can actually go plug in the router at the host site and have that capability without expending the cost. Also, up at the top, you can see we're going to be coming out with a common REST API and connection to the SMS for the test equipment to be able to do different modes of testing, and that'll be coming soon. Test station at the test laboratory. Basically, each test laboratory will provide an operate test station through Teams, allowing hardware control if required to either test equipment manufacturer or the device provider through a different set of tools. They typically are run each test station with a Windows 10 computer that has a Ethernet port to it, connecting all the components together. And if it's a wired test, you should be doing as a attenuated with some attenuators in line. Each device provider should have their devices loaded with certificates using a TCI version 2 or greater, and also provide the operating instructions. And in the middle of the week and the last of the week, each test laboratory should be providing their test case results to Aaron so he can consolidate them together and we can see how everybody is doing in an anonymous way order to say, yeah, the test cases have been proven out. We have had multiple devices and test equipment to be able to do them successfully, and we can approve the test case that gets approved in the scope. This is a listing showing all the test equipment that's participating in Plugfest versus the standards elements and what radio mediums they provide. So we got a whole host of capabilities here, and hopefully the device manufacturers are taking advantage of sending devices to multiple labs to get a variety of testing in different ways. Here shows the 6 testing location sites. We're here in Austin doing field and a few bench testing. So we're doing that. We have DECRA, who has a whole host of test equipment and devices that's testing this week, mostly in the C2V2X realm. Then next week, we have Bureau Veritas and TTA that will be testing. And the third week, we have SGS and Bureau Veritas in Detroit. Here in Austin, we have Aaron and myself doing the testing, and Aaron will be going to Bureau Veritas in Detroit to test there, and I will be either attending the Detroit or San Diego where needed. This slide here shows the standards being applied to the Plugfest and certification testing. There's probably not been a time in the last 10 to 15 years that more standards than V2X is going on in parallel that are being worked as there is today. There's probably about at least 10 different standards that are being developed at this time. We have the 3GPP and release 14 that's been released. We have 1609.2 security services that have been released, and actually 1609.2.1, which is the SCMS. Actually, we got notice this morning that it passed the committee review, and it's actually on its final executive review and should be released here late this year, early next year. We have the 1609.3 network services that have been updated for C2V2X. It's currently going through a 10-day ballot that ends next week. We're hoping that will be released in the early part of the first quarter. We actually, down about middle of the chart, J3161/1, which is the OBU LTE V2V requirements, is going through. It actually passed a 20-day ballot here a few months ago for more than 75%. They did some updating to that to take care of some comments from that 20-day ballot, and it's now currently in a 14-day ballot. The J3161/1A, which is the field performance testing, it's in a draft mode right now. It's more or less a duplicate of 2945/1A procedures, which was just released in July of this year. And actually, we were, with that release of that standard and the test case procedures approved through the technical working group, we were able to qualify the Southwest Research Group here a couple weeks ago to gain qualification status and officially part of the certification release. Also, there are other activities going on for RSUs. We worked very hard in the TS10, where it's serving both radio technologies, or it's basically radio neutral technologies, and it allows us to adapt the RSU 4.1 for the RSUs with select cases, so we can actually bring out the certification scope for RSUs later this year. Also, down below, the 1218, which is a standard between RSUs to the network. It's going through its final administrative process and should be released any day now. This shows all the test cases that are being done for this DSRC to V2X. We're actually testing, it's a 10 megahertz channel at 172. We're also adding testing at 180 for devices in place, because we anticipate that that will be the channel that the FCC NPR will be directing its use on. Here's a similar listing for the C to V to X, which is a 20 megahertz band as channel 183, and according to these standards. At the test locations, there's a multiple set of test equipment offerings that I hope the device manufacturers are taking advantage of. Decra has the Keysight, Spirent, Rhodian Swords, Aritsu, SAE, Danlaw, and the Vector test systems at their location, doing both bench and field. In Austin, we have the Southwest Research Tool, plus Spirent, Rhodian Swords, the North Systems, and the SAE. And in Seoul at Beer Verdes, and at TTI, they have the Spirent and the Keysight systems there. And also under TTA, they also have the Wades test equipment too. In Detroit, they're going to have Keysight, Spirent, Rhodian Swords, and Danlaw, and an SGS, Keysight, Spirent, and Aritsu. This is the DSRC, the Sniffer test case that you've seen me carry around for a couple years. It has a 4-channel DSRC sniffer, which is on the lower left-hand corner, the white with 4 antennas sticking out of it. It has a 20-watt battery supply in it. It has a shark fin antenna with an Ethernet switch, and we actually took some testing in the Austin downtown area at its 12 RSUs. I'll play this video. Hopefully you can hear the. So that was a snippet of what we did out in the field last week. There are BSMs, which are colored in navy blue. There's the single phase and timing, or the SPAT message, that is in orange. There's some black messages, which are WSAs, and there's some TIM message that was scrolling along there. In the upper left-hand corner is a Southwest Research Tool, where it has a ground truth accuracy unit, and doing different modes of testing, which I'll describe a little later. In the upper right-hand corner, you show the radio interfaces with the channel and basically the number of message it was receiving and its rate. From that particular test case, we developed a C to VX sniffer simulation case there. In this particular case, there's an intrinsic roadrunner, which acts as a C to VX proxy with a DSRC padding UDP forwarding. So basically, it receives the messages over C to V to X. It basically adds the 802.11 padding and basically sends it through its UDP port through a wired RJ45 interface into the Southwest tool, or now we can actually implement it directly into a V2X Wireshark and basically decodes just like you've been decoding a DSRC message. There's a 100-watt battery there you can see in the picture. We have a 8-port PoE switch. We have 2 magnet roof mounts, one in the upper left-hand corner, a small one, then a bigger one that goes on top of a vehicle roof, which is in the upper right-hand corner. We have two transmitting C to V to X devices. You can see in the center we have a Savari C to V to X OBU, and on the right side you see a tablet showing the statistics of both transmitting and receiving from consignia. The consignia unit is actually in the case underneath the antenna cable wirings on the right-hand side there. And then we attach a laptop with a Wireshark V2X decoding. Also, right beside the battery supply on the right side, there's a V2X hub Nano Pi. And that Nano Pi, which is a message generation verification, it'll be part of the next certification release. It basically will test the SPAT from a single controller 1202 perspective. It also will be testing, generating, and verifying the map messages and also the SPAT messages. We'll be doing this V2X hub message testing on the RSUs present at the City of Austin site this Thursday morning with the help of USDOT Saxon Labs Leidos, who have actually developed this open source software platform. And we'll also be testing on the RSUs that will be at Detroit on October the 15th. And we've actually received a couple of requests from our test laboratory folks and our test equipment folks how to go build one of these. So we're planning a separate meeting order to build this peripheral. So basically you need to get your device on order. This Nano Pi encasing costs less than $200, and hopefully you have it in hand. And when we do hold this section, Aaron and Amesh from Leidos will be going through those steps to showing to build them and its implementation. Also, I was invited to speak at the ITS World Congress that's been going on last week and for the next 3 weeks on the USDOT panel from Deb Curtis. On that panel, there was Larry Head from the University of University of Arizona, excuse me. That is really one of the nation's leaders in RSUs and working SPAT and MAP. And then we also had a director of Colorado as far as implementations and myself. That session will be shown, I believe, on October the 7th. So please go to its listing and see that presentation. Now we're getting into all the test equipment that's being at the test laboratories. We basically have the Dan Law test system for DSC using a National Instruments platform that tests both the Radio Phi and also 1609 and J2945 that will be at the DECRA Spain and also the Detroit, Vero Verdes Detroit location. We have the Ritsu test system, C to V to X, which tests the 3GBP PC5 test cases, and along with the J3161, and their test system will be shown at SGS San Diego. We also are having Keysight, who has a full test system testing C to V to X, along with what they did on DSRC. This basically goes through the full set of radio testing from 3GPP to the J31 radio aspects, to the 1609, to the J2545, and also has the capability of testing V2X applications and simulation. This particular test equipment is shown at most of the sites where it's being used at the DECRA Spain, also BV Korea and TTA Korea, also at SGS San Diego, and also at Bureau Verity's Detroit. The next offering is we have a C2V2X Sniffer tablet where North Systems, who's in relationship with Keysight, has developed this tablet. They originally did it in DSRC, which was shown at the Malaga, Spain Plugfest last fall. They have actually created a C2V2X version, which will do the showing the visual displays of the maps and also showing the decoding of the messages. And this tool is will be at DECRA Spain and also here at the city of Austin. We have Rody and Swartz, who are here in city of Austin and also will be showing at DECRA Spain, where they have a unit where can go through the radio layers in 3GPP, and will also has the applications for 1609 and J2945 with their relationship with Vector and their Canoe software. So very wealth of V2X testing capability. We have SAE, where they do both a benchtop test set equipment and also a portable sniffer. They were at the Spain Plugfest showing their DSRC capability on the National Instruments platform. It's also been converted and expanded to C2V2X, where it can do a variety of testing in lab, in field, and in vehicle. You can see their product offerings here, where it'll do the signaling layer, the protocol layer, and the RF layer. The Sniffer, C2V2X and DSRC, it's, I actually got to see it for the first time this past Friday and demonstrated with it. It actually has quite extensive capability of doing both the 802.11p and the LTEV. This particular test tool will be shown at DECRA Spain, the city of Austin, and we're looking to see if we can expand this showing at Bureau Verity's Detroit. Aaron and I was able to see this on Friday, so we actually put it to test on Saturday. So we created this video here. In the upper left-hand corner is a ADB stats coming from a Savari C2V2X OBU. And on the right-hand side, we have a status analysis from Consignia, where it shows the messages it's being transmitted and also being received. And lower is a Wireshark capturing of the different elements here, and I'll start the video here.
Hey, Randy, it doesn't appear as though there's any sound coming through for the video.
No sound?
Speak to
Okay.
it, yeah.
Okay. Sorry about that, without the sound coming through. It did work earlier today in the presentation, so I will scroll through a couple screens and describe. You can see here it has the upper layers of the headers and that stuff you see in a normal message coming through. You can see in its payload, it has a 1609.3 header, a wave short message. You can see the PSID number. You can see in the J2735 a basic safety message where it has the core data or part one. Also has the part two data here shown. Let me scroll. Okay, you can see the message count. Excuse me. The GPS location. The speed should be 0 since we're stationary. Shows those different elements. So also this shows the configuration here as far as the setup, where the C to V to X we're doing a channel 183, which is 5.915, and it has the size of subchannels and number of subchannels set at 10, 10, and start at 0. It also has some additional capabilities here, which has a visual subframe timing indication. You can see the ground noise at -60 and -7. You can see the two devices transmitting, which is the white line and the red line from the two devices. It also will give you other information as far as the RLC, the MAC, and this is part of the PHY layer portion here. Also has a events delogger here, which you can see here, where it gives more detail. And the most important block here is a basis, kind of shows the whole header portion of stuff, or the MCS resource blocks, the time gap, but the key item is the CRC status, whether it's good or bad. So it gives a wealth of information. So that's the end of so-called our initial testing of this. Then we have the Southwest Research Tool, which you've seen at previous Plugfest. It basically does the BSM analysis of the message and its content, while also showing the location accuracy in the field. It actually, we're proud to say that it gained OmniAir certified qualified test equipment status in this past month. And this particular test tool is being used at the city of Austin test location. This actually shows the test tool in my testing case, where actually I can set the case in the car, strap it down, and ready to go. It also has a battery supply to give a constant voltage, so you can turn the car on and off and not disrupt the testing or its accuracy. The testing locations are all being done by authorized test laboratories. We do have a new component coming in OAFTS, which is authorized field test sites, and our previous in-person Plugfest that was hosted by Southwest Research, UL, Intertech, Texas Transportation Institute, Transport Canada, and DECRA Spain. starting back in 2017 to the end of last year in 2018. We're basically going to a Plugfest concept with virtual witnessing being offered in Austin by DECRA in Spain, by TTA in Korea, Bureau Verdes in Korea, and Bureau Verdes Detroit, and SGS in California. So we're expanding the globe and offering testing for everywhere that V2X work is occurring. City of Austin, this shows the tools that are in place there, such as a drive test with a Southwest Research BSM analysis and location accuracy, the Sniffer test tool with multiple OBUs and RSUs in the field. We have the Norsum Sniffer tablet, the SAE Sniffer tool, the Spirent 1609 and J29/1 testing for both C2V2X and DSRC, and also the Rhodium Sorts vector system. This also shows some of our testing routes, and that's up. This shows the middle of downtown, where they basically have 12 V2X RSUs hung and broadcasting both WSA, SPAT, MAPS, and TIMS. And at our DECRA site, they have the Aritsu, the Daml, the Keysight, the Rhodium Swartz, the SAE, and the Spirent test systems doing both field and bench there. TTA Korea, who is an authorized lab for both OBUs and RSUs, the same as DECRA. They are offering the Keysight DSRC equipment there. They're also offering the Spirent 1609, both DSRC and LTE equipment. And they also have the Wades field test tool to be able to do the drive test and the location accuracy. BV Korea, they actually have a Keysight unit and a Spirent workbench doing V2X testing. And SGS, we have where they're doing both the Keysight, the Spirent, and the Aritsu testing in C2V2X. And last, we have Bureau Verdes Detroit, which has in the DSRC realm a Spirent test system, a DANLAW, and they also can do the drive test in C2V2X. They got the Keysight and the Rhodium Swartz testing there. And moving forward in C2V2X, we certainly hope the NPR from the FCC comes out with a directive that allows the FCC regulatory equipment type granting capability. We need standard releases from 1609.3, J3161/1, and NEMA TS10, which are all in their final stages of review and approval to be able to reference from. We'll be finalizing our test cases from this Plugfest test results. And so the initial C2V2X test scope can be released. Then we have the test equipment learnings and finalization for test qualifications and the test laboratory audit with qualified test equipment so they can offer the services. Are there any questions for me? And I believe Kate is going to be coming on, and I thank everybody for this evening session of the OmniAir Plugfest activities.
Thank you, Randy. Hello, everyone. I'm Kate Oldham, Senior Director of Meetings and Membership for OmniAir Consortium. I wanted to take a moment to thank you all for joining us today for our very first virtual Connected Vehicle Technical Workshop. I hope that you found today's sessions to be informative and useful, and we hope that you'll be coming back tomorrow to join us again. We'll hear from our keynote speaker, Lars Rieger, from Chief Technology Officer of NXP Semiconductors, followed by a panel discussion moderated by Mike Brown of Southwest Research Institute, covering public sector perspectives relating to V2X deployment and testing, and a fireside chat with AECOM Suzanne Murtha and ITS Canada Board Director Yaitlin Wong regarding connected vehicle market trends in North America. Finally, a discussion about new advances in test tools for cellular V2X, led by Justin Johnson of 3M. So again, thank you all so much for joining us today for day one. We hope that you enjoyed it, and we hope to see you all again tomorrow. Thanks so much.